Arizona Science is supported by Research Corporation for Science Advancement.
For AZPM, I'm Leslie Tolbert, Regents Professor Emerita in Neuroscience at the University of Arizona, and this is Arizona Science. Today we're talking with Jeff Pyun, Professor of Chemistry and Biochemistry and also Optical Sciences at the U of A. Jeff will be giving the final talk in the 2024 College of Science Public Lecture Series. Welcome, Jeff.
Thank you, Leslie. It's great to finally be here.
You will soon be presenting the fourth and final talk in the lecture series, and this year's theme will have been surprise twists that transformed science. What's the particular twist that you are going to be talking about?
Right. So I think it's this particular series resonated, very closely with me because everything about what we have been doing in the past 15 years was totally unexpected in terms of discovering this new way of making polymers, having it have lots of sort of sustainability relevance. And I guess the big surprise that I would point out that's sort of a big picture, easy to follow, is that we take the waste of fossil fuels, right? So the waste of gas and oil, and we use that to make a new sustainable kind of material. So it's kind of like the people we normally associate with not being sustainable, right? The stuff they don't want is what we're using to make plastics in a different way.
And what even made you think that that was going to be something useful?
Oh, well, it's also a surprise, meaning that we didn't initially start this program with that in mind. So we came from a different sort of technological motivation. So like in 2010, we were starting a new program here for the first time at the University of Arizona for next generation batteries. And we were looking at a class of batteries that's known as a lithium sulfur battery. And hence that got us into sulfur chemistry and sulfur materials with the intent of making these kind of high capacity batteries. And then as we got into how we're going to make these kinds of new materials for this kind of device, we just sort of realized, wow, right? Where sulfur comes from, the story of, its abundance and need or absence of, chemistry and ways to use it, that became the bigger motivation for us to get into that as well.
So is sulfur waste an issue around the world?
The answer is yes. I guess the way to think about this is in the 70s, we had the problem of acid rain, right? Mm-hmm. And that's simply because without additional refining, there's a lot of sulfur-containing compounds in petroleum. And so as we put those into our cars and as we drive around, all those emissions go into the atmosphere. So that basically combines with different things like water and various kinds of substances, and that makes sulfuric acid, and that's acid rain, Mm-hmm. And so what the oil industry did in the 70s was actually quite remarkable. They saved us from acid rain. And because of that, they now basically generate, tons and tons of sulfur every year. Just to kind of remove and avoid that problem with acid rain, but that creates this surplus of unused sulfur.
So are others adopting your process already for a way to use sulfur in a positive way?
I think I would say it's certainly been adopted across the world, which has been exciting to see. And so numerous companies, both in the oil and gas sector, in the chemical sector, in the plastic sector, have developed programs based on the chemistry that we invented here. So that part's been very exciting to see.
And are you having an impact on the accumulation of non-degradable plastic waste around the world?
Probably not yet. It's taken about 10 years, I would say, for companies to finally recognize the potential.
So what do you see as the timeline? When do you think you'll begin to have the kind of impact you really want to have?
It's a great question. I guess it depends on which of the products and projects we're working on now have the easiest entry point. So it could be anywhere from a few years to decades. So we'll keep at it, hoping that one of these break through.
And will we know when we're using sulfur-containing plastics?
Maybe not. Maybe not. It'll be, be innocuous in things you see around you. It might be in devices. So one of the things that we're looking to develop here is in collaboration with the College of Optical Sciences, which is a world-class institution for that type of technology. And you might not realize it's in your camera and your phone as a lens material. So, it could be a wide range of possibilities.
Well, this is very exciting. Thanks very much, Jeff, for giving us this glimpse into the future.
Thank you for your time. It's really exciting to talk about this.
Dr. Jeffrey Pyun is pioneering advanced chemical methods of creating new sustainable plastics that have novel, useful properties and may help to reduce pollution in the long run. Thanks so much.
Thank you.
You can listen to this and all Arizona Science conversations at azpm.org/Arizona Science. I'm Leslie Tolbert.
Thank you to Research Corporation for Science Advancement for their support of Arizona Science.